Okay, this video is on the rates of reaction, or how fast a reaction is. It's basically the speed of reaction. Now, in a reaction, gas can be formed in this manner. When a metal reacts with acid, and what happens is gas will form, gas will enter into a stream where we can collect it, and from there we can plot a graph of measuring the time taken at different intervals for the different volumes. So measure the volume at different intervals, and then we can plot a graph, and from there we can see how fast the reaction is. Okay. Another way is by measuring the mass. Now in this case we put a cotton wool and a conical flask at the top. Now what's the purpose of the cotton wool? The purpose of the cotton wool is to prevent acid spray. Now if the reaction is vigorous, acid may spray out and we may lose the unnecessary volume. So what we want to do is we only want gas to escape. So in this case, let's say hydrogen gas escapes. This will result in a drop in the mass, the overall mass. So from there, initially this is the volume where time is 0 when there's no reaction. The reaction starts, hydrogen gas or carbon dioxide gas escapes, and the volume will slowly decrease. But notice that the volume doesn't decrease to 0 because you always have the product and the conical flask plus the cotton wool. So it doesn't go to 0, it will stabilize and the gradient will become flat, showing that the reaction has stopped. Okay, so example, if we are looking for the gradient of the curve, the speed of reaction for a particular point. So notice carefully, the volume of the gas is always 0 when time is 0, and then it slowly increases and then gradually it stabilizes and becomes flat. So if you are asked to find the gradient or the speed of reaction at a certain point, example here, okay, when time is equals to x, this is the point required. What you need to do is you need to find a tangent at the point, and from the tangent you will calculate the gradient based on the difference of y, difference of x. So the gradient is simply equals to change in y over change in x. And notice carefully, as the reaction time goes by and I plot, look at the gradient from steep becomes gentler and gentler, and eventually it will be 0. So in certain questions they will ask you to describe the speed of the reaction as it increases, so you can use the gradient to explain that initially it's very steep and then it becomes gradual and then finally it becomes flat when the reaction is over. Now, when the reaction has reached a maximum volume and it doesn't change, it means that one of the reactants is used up or both reactants are used up. So in this case, no more gas is produced, so it stabilizes. Okay, because when no more gas is produced, volume remains constant and reaction is over. So to find out the time taken for reaction to end, what you do is you find the maximum time taken and when draw a horizontal line, once it touches the volume, drop, and this is the time taken for the reaction to end. If you are asked to find the time taken for the reaction to be halfway through, okay, find out what is the half. Okay, the example, and let's say I'm doing a rough one. Half the volume will be half the reaction. Okay, do the horizontal and drop. This is the time taken for half the reaction to end. So find out half. Now the speed of the reaction and the rate of reaction are affected by 5 factors: concentration of the solution, surface area of a solid, temperature of the solution, pressure for gases, and catalyst for some reactions. If a reaction is faster, so let's say this is the original reaction, blue is the original reaction, reaction 1. If the reaction is faster, the gradient will be steeper and the reaction will end earlier. Okay, time for reaction to end will be around here earlier as compared to here for reaction 1. Now if the reaction is slower, the gradient will be gentler compared to reaction 1. Okay, so reaction 2 is slower and it will take a longer time for it to end. Now take note, catalyst doesn't apply for all reaction. Only certain reaction catalysts can be used, and different reactions will require different catalysts to react.